Alright guys, welcome to 10.8 Video Notes. We're going to be looking at similar figures and how we can make scale drawings with a given scale factor. So let's talk about what Jessie is using a map to travel from her home to the state capitol. She measures on the map to find the route is 4 inches long. The scale of the map says that 1 inch is equal to 20 miles. How could Jessie determine the number of miles she will travel to the state capitol? Okay, well, similar to 10.7 with proportions, Jessie could set up a proportion to determine the number of miles she will travel. So we're going to be using proportions to find out the missing links inside of a scale drawing. Okay, so let's see how we can do that. So similar figures have corresponding side lengths that are proportional. They have a common scale factor. So when two figures are similar, a proportion or scale factor can be used to find the length of an unknown side. For instance, we need to find out what EF is, the length of EF is. We know AB, we know BC, and we know what DE is. So we can set up a proportion to find the missing length. So go ahead and pause the video. See if you remember how we can set up a proportion for this. Alright, so I did AB over BC. Now that should be equal to, the sides across from it should be equal to the corresponding side. So what side is corresponding to AB? AB is corresponding to DE. So DE is across from it. And then EF is corresponding to BC. So those are across from each other. Now I'm going to plug in the numbers. So AB is 6. BC is 8. DE is 4. And EF is X. We don't know what it is. So now you guys love cross multiplying and dividing. So cross multiply and divide, and you get X equals 5.3 repeating. Okay? Because this is equivalent to 6 times X, which is 6X. 6X equals 32. Divide both sides by 6, and you get X equals 5.3 repeating. So that's where that comes from. Okay? All right, number 1. Trapezoid ABCD is similar, which means that corresponding angles are congruent and corresponding sides are proportional. So these two trapezoids are similar to each other. What is the length of RS? Well, let's set up a proportion. So we have BC over AD is equal to, which side's corresponding to BC? Well, that would be RS over QT, which is which is QT. Now, go ahead and pause. I'm going to pause the video. You go ahead and plug in the numbers into this proportion. All right, guys, should have plugged it in. You got X equals 8.4, which means the side length of RS is 8.4 meters. All right, number 2. So it tells us that the perimeter of GHI is 40 centimeters. If the triangles are similar, then what is the length of JL? Well, perimeter means it adds up all the 3 sides. Right? 15 plus 15 is 30. 40 minus 30 is 10. So GI has to be 10 centimeters long. All right, so now we can set up a proportion to figure out what JL is equal to. So go ahead and pause the video and see if you can set up a proportion to solve for JL. All right, here's my proportion I set up. I picked GH and GI equals JK over JL. Now you want to make sure that you have to pick the side that you're solving for. So you have to have GI and JL somewhere in your proportion. Okay, now go ahead and pause the video and put your numbers into the proportion and solve. Alrighty, you should have gotten 6.6 repeating will be the side length of JL. Okay, and if you want to write it as a fraction, you could write it as 6 2/3. So either one of those would be good for me. Alright, go ahead and read number 3 and then come back to me. Alright, so number 3, we're given a bunch of information from these triangles, okay, and we're told that they're similar. Bethany says there's more than one proportion that can be used to determine the missing side length X. Do you agree? Justify your solution. Well, let's test it out. Let's see. Remember, we're solving for LM. Why don't we start with HJ? hj over jk equals lm over mn. So that works, right? The sides are proportional, but what if we use ln and hk instead? So let's try hk over hj equals, hk is proportional to ln, so that's all good. And then last but not least, lm. That would also work, right? So yes, since multiple dimensions are given, multiple proportions can be used. Okay, so we can use multiple different proportions since multiple dimensions are used. Okay? All right, flip it over. All right, let's talk about scale drawings real quick. So 2 and 3-dimensional objects can be represented with a scale drawing or a scale model. An example that you might have seen in social studies is a map. A photograph can be used as a scale model or drawing. Blueprints are big in engineering in the tech field. Okay, so let's use that knowledge to see if we can find the scale factor of some scale drawings. So number 4, the photo below will be enlarged, means a scale factor larger than 1, to form a 16 by 20 print. What is the scale factor needed to enlarge it? So I'm just doing a little sketch. 16 inches would go on the side, 20 inches. So how are we going from the small shape to the big shape, right? Let's try it. Scale factor. K is your scale factor. New divided by factor, your new. We can pick this side or this side, right? 20 divided by the original, which is 5. 20 divided by 5 is 4. So your scale factor is 4, otherwise known as your K value. All right, number 5. A tree casts a shadow that is 9 feet long at the same time a person is standing nearby casts a shadow that is 3 feet long. If the person is 5.5 feet tall, how tall is the tree? So we can actually draw triangles to show this representation. So if we have a tree, right, its shadow would kind of be going this way. We're told it's 9 feet long. We don't know how tall the tree is, so that's my X. Now let's talk about the person. The shadow this person cast is 3 feet. He is 5.5 feet tall. We can use this proportion, we can write a proportion to solve for the missing height of the tree, right? We could do 3 feet over 5.5. Now the corresponding side to 3 would be 9 in the tree over X. Cross multiply and divide and you get X equals 16.5 feet. So that's how we can draw pictures and then set up a proportion to solve for a scale factor or a missing side in a scale drawing. All right, I want you to read number 6, and then we're going to do number 6 together. All right, so number 6, we're dealing with the map. So first, we want to start off with drawing the proportion, where it's the 1 inch is over 80 miles. And we can set that equal to. The distance between Austin and Corpus Christi is 232 miles. So miles would be on the bottom as well. And then we don't know how many inches these cities are apart, so that's X. Cross multiply and divide, and you get X equals 2.9 inches. That's how far those two cities would be on the map. Alrighty. We're going to skip number 7. Okay, so we're going to skip 7. I want you to go to number 9. So we're skipping number 8 as well. All right, guys, so we need to write a proportion to solve for EC. So let's go ahead and write our sides out, our proportional equation here. So let's start with AD. AD over, now we need to make sure we set up this proportion to solve for EC. So I need the corresponding side to EC, which would be AE. That would be DB. What's corresponding to AE? That would be EC. So now we can plug in the numbers. So AD is 7, AE is 5, DB is 21, and EC is X. Cross multiply and divide, and you get X equals 15. So this side length is 15. So guys, go ahead and pause the video. You guys should be ready to go on into the must do and then ace that mastery check. Good luck, guys. Great job.